So, hello. As we've just heard, I'm Niklas. This is my DIY presentation program Power Slide. Here is my first slide with my name on it. I come from Berlin. This is my little workshop. This is where I work and live. Then I also have a website. This here. I will try this clicker now. So I make art with technology, which means I basically work with electronics, with coding, I build hardware. I like to do all this stuff by myself, and I always try to make different things, but in this talk I just want to show you a selection of machines. Two of them have been actually last year in the show in Under Construction. So for those who have seen the exhibition, now you learn a little bit about the background of them. The title of the talk is, I have the clicker, is Vectors, Pixels, Plotters and Public Participation. So this talk will be about drawing machines that involve urban space and participation. And for the beginning, I want to clarify. I want to clarify these terminologies and concepts here: collaboration, participation, interaction. They are all about different levels of involvement with an artwork. And let's start at the bottom. Let's start with interaction. So interactive art is art that goes beyond passive observation. Often it is an artwork where it reacts to the viewer. That might involve code and electronics. And then on the next level we have participation. So this offers a deeper level of involvement with the artwork of the audience. And the audience is also taking a different role, the role of participants. And they contribute to the artwork. And then on the next level, we have collaboration, where two or more people are working together to create an artwork. And those can be artists working with each other or artists with professionals from other fields like scientists, technologists, and then they create an interdisciplinary artwork together. And most important is that this can all overlap in many ways. So it's perfectly imaginable to create an interactive artwork within a collaboration, for example. So it turns out that machines can actually be quite helpful for collaborative and participatory processes. And therefore I want to show you three machines which I made in the recent years under different circumstances. And I made other projects in between, but they three are somehow related with each other and they build on top of each other. So the first one is the Graphomat, that is a large-scale graffiti plotter. The next one, which I will only cover briefly, is the vector collector. And this binds the first and the third project together. The third one is then the mosaic machine. And some of you might have tried it out last year. With that, I built that to create a so-called Maschinenmosaik, but more about that later. So, project number one, the Graphomat. This was a no-budget but fun project that I made in spring 2021. So it was one of those COVID lockdowns again. I had quite an empty calendar, nothing was happening. But close to my studio, there was this graffiti wall. In the graffiti jargon, this is called a hall, or comes from Hall of Fame. So the idea there is it's a legal graffiti wall. Everyone can paint there. This actually goes around the corner, so it's two walls here. And I really liked the activity there, because there were constantly people painting something, and then when they were finished, the next person came and just painted over it again. So it was somehow, I really liked the mood, and I thought, I would also like to become active there, but my problem is I have no idea how to make graffiti. So I do know, though, how to make machines, so I decided to build a machine that operates a spray can. So it's not really making graffiti, actually. I also didn't want to compete with the graffiti artists there. I rather thought that I could make some interesting tool that we can explore together and somehow get to know those people. So at this point, let's make a short excursion in media art history, because when you're standing on the shoulders of giants, makes sense to check out what they've done before. And regarding spray can plotters, this here is Hector, built in 2002 by Jörg Leni and Uli Franke. That was a very successful art piece, has also been shown at MoMA and all around the world. And it's a very clever design. It's a polar plotter that has these kind of two motors here, and the spray can is hanging in between. The design has been adapted by many people for different purposes. And I've been also in contact with Jörg to discuss my project, and he shared some knowledge with me about spray can plotter stuff. So looking further back in history, there is a second inspiration. This is the Graphomat Z64, built by the company of Konrad Zuse in 1961. This was the first pen plotter, so this is actually the invention of the pen plotter. Was widely used by the pioneers of generative art. And it has this classical XY design, and I actually stole the name and the design principle from this machine. So to understand how such a plotter works, welcome to how to build a plotter or a spray can plotter. So in my experience now, there are actually two ways to build a machine, how to approach it. The first approach is to start with the outer shape, and then you try to fit everything inside. Or you start with the smallest part, the most crucial part, and you think about what it has to do, and then you build everything around it to, well, make it happen. The first way, this building from outside to the inside, that is really useful if you have to ship it afterwards, or if you want to still get it out of the door of your studio, your contraption. While the second part is the second way to build, so starting from the smallest and let it grow. That is a really good approach, I think, if you don't really have a big plan in the hand and you just let it grow somehow, the whole thing. So I built it quite quick and dirty, my plotter, and went for the second way. And I had a spray can, and I also had a cordless drill with a broken battery. And what is really nice about those cordless drills is that it is really easy to attach mechanical parts to it, like a pulley, and then take a second pulley, and then you take some rope in between. I took some washing line, and that way I could move a spray can left and right. Then my neighbor had actually also the same thing. He also had this cordless drill, also with a broken battery. It was those cheap ones from Aldi, actually. And I used this to lift the first mechanism up and down, and that way I could move the spray can in all directions. But of course, I didn't want to do this by hand, so I had a controller that was operating those two motors. And then there's one problem, some might spot it already. The controller doesn't know where the spray can is located, so you need some sort of a position feedback. I have used optical encoders. These are actually strips with black and white stripes. And then when you use some sensors, some optical sensors, the controller can basically just count, and that way it knows where the spray can is located. So there are two more things missing. One thing is a data source, because the controller has to know where it has to move the spray can. In my case, that was some little SD card reader. And then you need a power source. There I took a motorbike battery. So these are the specs of the plotter that I've built. It was able to plot in an area of 2 meters by 2 meter 20 with a bad resolution of 1 centimeter. And these are the real devices. So there you see at the bottom, this is the controller for the plotter, and on top, attached with Velcro, is the SD card reader. So the next slide will be a video that I've taken with my phone of the machine in action. It's unedited. There I was experimenting. It was of the very beginning. There I made some experiments with raster images. and I didn't want to use the stereotypical images which are used in computer graphics for testing out algorithms and stuff, so I thought I'd take the portrait of Konrad Zuse and spray him. And they can also recognize that the thing is actually quite loud because of the drilling machines and quite slow also. So this makes it actually quite unattractive for illegal activities. Let's have a look. So thank you. So when I returned later back to the wall, that was actually quite funny because the graffiti artists, they were totally confused how this was created. The ones who have not seen the machine, they thought, who is standing there and making all these dots and makes a face? And then they were also super confused about why did you choose to spray a portrait of Erich Honecker there? So just for clarification, on the left side, we have computer pioneer Konrad Zuse. On the right side, this is Erich Honecker. For the younger ones, he was the leader of East Germany from 1976 to 1989. So now that you've seen the plotter in action, let's also have a look at the techniques and materials that I used to build the plotter. Spoiler, this is nothing fancy here. This is just stuff from the hardware store. So this is the spray can mount. This is built out of plywood, which I just cut with an electric saw. And I didn't even make any 3D plans or something. I just made some scribbles on paper and then I cut it out and tried it out. And of course it didn't work and I built a second version. But it went really quite fast to make this. And it was really simple to make it also. So then I also attached all the stuff just with zip ties and tape because zip ties are cheap, lightweight, easy to use, don't cost much. Ah yeah, they're cheap. I said this already. So these are the linear bearings. This is electrical conduit. This is this PVC pipe for electric cables. And this is just gliding over aluminum pipes. And the encoder strips are just made out of adhesive tape. And then I also like to use this material here, Forex. This is some PVC foam board that you can easily cut just with a hobby knife. Can also recycle it quite well. There are a lot of those signs outside of the KIKK festival made out of Forex, and actually in the past I recycled a lot of the KIKK signs already for my stuff. So this goes much faster than 3D printing to build enclosure. And also with the electronics, that's quite simple. I used a lot of modules and then I just connected them with some perforated prototyping board as a main board. For the software, I wrote a really simple Arduino firmware for it. And the problem there was that it was so simple that it could not even read any existing vector file formats. So I came up with my own vector image format, the .plt format, which is basically just a list of coordinates in a text file. And when you have your own image format, you need a way to edit this. So in processing, I also wrote an editor for PLT. This was the workflow. Starts with a drawing program, goes on SD card, and then I can plot it. So, but back to the hall, let's look at some collaborations, what I've done with it. So this person goes by the name How to Kill a Graffiti. He makes these super large scale, very experimental and artsy organic shapes and bodies. And he really liked the plotter and he wanted to incorporate it in his large paintings. So he did some experiments with rasters. And then with this entire scene, we have made a lot of wild experiments at the hall. And we were also brainstorming, so what could we do next? So what would be a cool thing? And the idea came up to make a blueprint of a really long train that we plotted in segments. So we were moving the plotter in between. And the idea was that everyone could spray on it, because, you know, graffiti artists really like to spray on trains. Here's the finished train. So some experiments were also a total flop. For example, I experimented with different caps. So you can exchange on spray cans actually the nozzles that you put on top and buy different ones. And for the next thing that I will show you, we used a cap that was actually super drippy, which I didn't know beforehand. But so it became more drippy than we wanted. This is an experiment that Carolina Romano has done together with Arturo Castro. Some of you might know them. Carolina is an artist who works mainly with Blender and does 3D stuff. And Arturo, he is one of the core developers of Open Frameworks. And he wrote a Blender plugin to export PLT images so that we could make an animation with a plotter. Here's a video. All right, so up to now it was all about, thank you. Up to now it was all about plotting data from the SD card with the workflow that I've shown, but I also want to show you at least one of the alternative inputs I was experimenting with. One was actually very, very simple. It was just a joystick connected to it. And as you can imagine, standing in front of the wall and then plotting there's something in real time with a joystick is fun. And well, everyone had fun with it. But we also made other experiments. For example, one IoT experiment where you could control it from at home with a keyboard on the computer and you could observe it via webcam. But you can check this all out on the project documentation. One nice thing is also that, of course, I met a bunch of new people, made some friends there at the graffiti wall. So these are all people who collaborated with the plotter with me there. Feel free to take a photo and check out their profiles later. So, but now we come to the next project, the vector collector. So, as I said, I will just cover it very briefly. It's a low budget production, so we are getting more expensive from no budget to low budget here. And I've done this together with Kati Hüppe in 2021. There we were both invited for an artist residency to Chemnitz, that's next year's European Capital of Culture in Germany. It was a 1-month residency, so not too much time, and there was a theme for the residency that was drag and drop. And we thought, let's build a machine that we can drag around the city, and we drop it everywhere, and people can do something with it. They can make drawings, and then they get their drawing at the end officially stamped and numbered. But we, at the same time, get all their data on SD cards, so we were basically just logging how they were moving the joystick and what they were drawing. So it was some sort of a data collection machine that we have built. And we had this mechanism of a broken plotter. It was just a normal pen plotter from the 80s, and we turned it alive again with a hack out of gear motors, some rotary encoders, a lot of hot glue, some Arduinos. And then I basically just recycled my self-written firmware from the graffiti plotter and modified it a little bit, put it on that machine, because it had to be built very fast. So the result was this drawing machine, which is a little bit stupid because it just makes drawing more complicated than just taking a pen and drawing something. But turned out that people really liked the machine. I think it was because it was a curiosity. And we dragged it around in the city and let different people draw. It was quite easy to find people to participate because of the funny appearance, because it was a novelty, and maybe also because it had built-in music, so we were playing constantly some happy chiptune style music, and it actually created some sort of a social space right away, the machine. So our entire setup was even a bit larger. We had this extra table with a mechanical typewriter for collecting metadata. So there we wrote down the date, the location, the color of the pen that the people used. But we have decided not to collect any personal data of the people, no names, nothing. And if you're doing something like this, I can tell you that mechanical typewriters was just 30 euros on eBay, and it was a total hit amongst the kids. They loved to play around with it. They've never seen this before, and it was perfect to keep them busy until they had their turn on the vector collector. Here's how the data looks like. Again, it's just a bunch of numbers. And because it was recording every pen movement, it was quite easy to turn those numbers back into animations. So we made a project website where we showed all the drawings as animations, but we also had a vector archive on the website where you could download all the drawings and do something with it. It's all public domain, so you can do whatever you want to do with it. So since this was all a quick hack, the way to get the data from the SD card to the website is shown in this diagram here. So I don't want to go into detail, but actually I had to do a lot by hand every evening and put it in this program, get it out there, copy the data there. It was really, really evil tool chain. And I think this idiotic procedure really shows how the thing was also built. It was just growing, growing, growing on top of really, really old code. But the advantage of growing an old code is that it was all compatible also with the graffiti plotter. So we could use the drawings and spray them on some walls in Chemnitz. So to finish up this project, I also want to show you a video of the machine in action. merci. I should have another merci also in there. I just have thank you. I also have, if you wouldn't react at all, I would have an applause also. Thank you. Next time I will come with merci. So, project number 3, the Maschinenmosaic. That happened at the beginning of last year, so this is some sort of a culmination of the other 2 projects. It's created with a bigger team and a bigger budget because it was the result of a public art competition. And the background there is, so it's the historic background about the place where this happened. That was East Germany's first prefab quarter, built about 50 years ago. Actually quite close to my place. And right from the beginning, they had these public artworks on the facades and at the place there. Here is another one. And most of those beautiful artworks actually disappeared over time due to renovations of the buildings. The name of the place is Anton-Sivko-Platz. This is how it looked like at the beginning of last year. So as you can see, a lot of graffiti and tags. No one was happy about it anymore. And for the 50th anniversary of the area, the city of Berlin decided to have this art competition. And they were looking for some participatory artworks for those walls. They also were looking for something that prevents future vandalization, is how they wrote it in the call. And I did not want to make something against graffiti, but I rather thought to bring this spirit of graffiti to those walls, that this might be actually a good idea. So those competitions work like that you write a text and you also make a poster where you try to communicate your concept. And I doubled down a little bit on the vector collector idea, but this time with pixels. I thought to build this arcade machine with which I could collect pixel drawings. People would get a printout of their drawing on a piece of receipt paper. And then we would also collect the data, of course, cut all the motifs into stencils, and then with the graffiti friends, the idea was to make a mural out of it. And well, the reason why I present this now, because I won this competition with that concept. Thank you. And this is the real machine here. So on the left side, you see the machine. On the right side, a close-up of the interface. So I just want to quickly say something about the interface. What I've discovered is that I find it really important to make those things really, really simple, because people don't want to spend time learning interfaces, and I don't want them to spend time. I want that they can draw right away. And one thing that I also discovered over the years is that with such interfaces, it makes sense to build them symmetrical so that left and right-handers can use them the same way. So you see that the black and white buttons are the same on the left and right side. And with that, the people could then make simple drawings. People tended to spend more time with this machine than with the vector collector, because they could also correct what they were drawing. But you can see it's an extremely simple program. So and at the end, then you pushed the green button, the thing was submitted. And you got such a printout here, also with a number that you could find it again in this online archive where it was uploaded automatically. So with this machine, together with my friend and neighbor Paul, we visited many places in the neighborhood, like the library here, but also a youth club. And then people were quite curious. This guy stopped me on the way home, and he also wanted to draw something. We've been at a community center. People really like those giveaways when they get a little piece of paper. This at the park. So it's always, I think it is super helpful also to be with the machine and to moderate this process, because that way you can also get in touch with the people. You can explain the overall concept of what you're trying to achieve there. The people were also quite diverse who participated, so we had really very young kids, but also very old people. And altogether, we collected over the course of 10 weeks roughly 500 drawings from different people. So now let's have a look at the technical side of the project. I will start with the hardware. My very first concern when I thought about it was the screen, because I thought this thing has to work in very bright daylight, so I need a really bright screen. Those things are expensive, but I had this old 4x3 flat screen in the basement, and I like recycling. So I took it apart, removed the backlight, and replaced it with a very bright LED ceiling light, and that way I got a really cheap DIY daylight display. Then you've seen, this time I made the 3D model, so I built it rather from outside to the inside. I made it out of plywood again, and the size of it is about 2/3 the size of a normal arcade cabinet. The reason there was, again, accessibility. I wanted that kids can use it well, and also people who are sitting in a wheelchair. But it also turned out to be quite practical for moving the machine. So now let's have a look what's all inside. It's all these things stuffed inside, but I checked it out with a 3D program that it all fits. And then I wired it all up according to this hardware block diagram. Here is another diagram. This is how the software worked. And I don't want to go into details, but just so that you know, this was all programmed in JavaScript and PHP. And this red block here on the top right is the drawing game. So this was basically running just on a computer in there in full screen in a web browser. And then it sent the data to the server. It was stored in a JSON file. The gallery got it from there. But there was also this layout tool here. So with that, I could easily grab all the different drawings that people have made and basically compose stencils out of them. So I could always place different motifs on one stencil. I could rotate them, resize them, and then create a vector file that I could plot with a cutting plotter. So the stencils, they all were 60 by 60 centimeters. The material was thick wax paper that we used there. We made some experiments, and this stuff turned out to work super well. And over the course of several weeks, we were plotting hundreds of stencils because the aim was really to use every motif that has been drawn with the machine. Here is a closer look at some of the stencils. So the idea there was also to start spraying with some background patterns to structure the walls, and then to put some motifs on top of them. And there was one thing that I didn't think through at the beginning, is the handling of hundreds of stencils. So what we have done then is we categorized them by motif and made different folders. So we had like geometrical patterns, nature, names, figures, and all kinds of other stuff. Then we went shopping cans, and we made some experiments at the skate park. And when we were happy with the results, we moved on to the real walls. And we painted them with wall paint. There we got actually really negative comments from the neighbors, because they thought that this is not worth the work what we are doing there, because someone would spray right away over it again. But when we started with the stencils, they understood that, maybe it's quite okay what we are doing, and they were quite supportive. Neighbors brought us even drinks and were applauding us for spraying there. So now let's also have a look at some pictures of the wall. This was during the process, just with some background patterns. Here we have some motifs on top. So we followed this rule that we just had everything always leveled, even more chaotic ones. This is a very simple one, stop the trash. And then we also had this tiny house at the square, which was our base throughout the project. And there we had also the machine installed and the plotter, so neighbors could come over and make some last-minute designs and then spray them even themselves here. So not everything was super leveled. We also had some sections where we broke our design principle because there also the idea came up that the drawings could fly out of the machine to explain the process. We have done this at the parking lot around the place. And this is how the finished walls looked like. So we had basically altogether 500 square meters, 4 different walls. We gave them themes, like this was close to the swimming pool where we put all water-themed stuff. Close to the park, we put everything that had to do with nature. There was a lot to discover on those walls, still is. It's actually still in quite good condition. And it was also really nice for the neighbors because they could, many of them kept their receipts, and then they were, when it was finished, they were checking and trying to find their motive on the wall, their contribution. So now we are turning to the parking lot where it gets a bit more crazy. And then behind the machine we put all the names. Quite many people wanted to write their names. And as I said, this was made with a larger team. So these were all friends of mine who helped me doing this. And here are their names. So it was not just a larger team, it also took a longer time. Here is the timeline of the whole project, several months from the start to the inauguration. And now we have the first unpixelated picture. This was the inauguration party where many of the neighbors came, some local politicians, the architect of the area, and of course the whole team. If you want to learn more about it, there are 2 websites, the project documentation on my website and then the project website. So let's come to a very quick conclusion. I'm here running out of time already. My main takeaways on the technical side is when you're working with large data sets, or when I'm working with large data sets in the future, it really pays off to invest in the process at the beginning and not to do all the stuff by hand. On the social side, those machines turn out to be really great conversation starters, but moderation also has a lot of value, so it makes sense to be with the machine and to communicate with people and to use the machine also to start a conversation. On the creative side, what I really like about the data sets is that they're really rich and diverse because so many different people created something. And in case you have any idea what to do with hundreds of pixel drawings or vector drawings, then feel free to go on my website. There you find all the data sets. It's all public domain, and you can do something with it. And well, that's it. Thanks a lot for all the applause. I also want to take a quick photo of you. Perfect. Merci. In case you have any questions, hit me up at the bar. I will drink a beer now, or we see each other tonight at the party. And well, if not, check out the next talk. It will be top funny, I promise. Bye, thanks.